Factoring is going to be a skill that we're going to need as we move deeper into polynomial functions, and so I thought a review of factoring would be helpful. You may have seen this already when we did the factoring unit. I can't remember which classes I gave it to and which classes I didn't. But we're just going to go through it again so that you can have a refresher. The first thing you want to do is always look for a greatest common factor when you're factoring. No matter what, you want to see if you can simplify those numbers a little bit. So just to refresh greatest common factor, you just look at your terms and you think, what do both of those terms have in common? What can I divide out of both of them? Well, 3 is a factor of both 3 and 6, and so is x. X will go into x squared, and x will also go into 6x. So then when I factor out my 3x, that's going to leave me with x minus 2, and that's factoring out the greatest common factor. And then in the next one, all I have in common is a 2. So I'm going to factor out that 2, and that leaves me with x squared plus 3x minus 10. And I could go ahead and factor this quadratic here a little bit further to be two numbers that multiply to give me negative 10 that add to give me positive 3 are going to be positive 5 and negative 2. So I can factor it to be x plus 5, x minus 2. So one of the methods we learned was difference of squares. It's one of the easiest ones, but for some reason students struggle with it. If you have two terms and they're subtracted and each term is a perfect square, then it's the product of the sum and the difference of the square root of each one, x plus 4, x minus 4. Same thing here. We've got the two terms that's a difference, and they're both perfect squares, so it's the product of the sum and the difference of the square roots of each term, 2x plus 3, 2x minus 3. The next type of factoring we looked at was grouping, and one of the signs that it's going to be a grouping problem is if you have 4 terms, and then you just treat each term, each of the two groupings, as if it was its own problem. So we're going to factor out a 3x here, 3x times x minus 2, and then we're going to factor out a 4 here, plus 4 times x minus 2, and then you pull out the factors that you have in common. They share the x minus 2, so that's one of your factors, and then the 3x plus 4 is left over, and that's your other factor. You can also have factor by grouping with 2 variables. Both of these have an x squared. That's all they have in common. So we can factor out an x squared, and that's going to leave me with 2x minus y. Here I can factor out a 5. That leaves me with 2x minus y. And once again, I have the part that matches, and I have the part that's left over. So the part that matches is 2x minus y. The part that's left over is x squared plus 5. So that's your factored form. And then over here, this is the quadratic trinomial factoring, or this is the AC method. Here we have a is equal to 1. So that's the easier of the two methods. A is 1, B is 3, C is negative 10. So I'm looking for two numbers that multiply to give me negative 10 that add to give me positive 3. We already did that. It's 5 and negative 2. We did it right up here. So because this is a 1, I can go straight to my factors, x plus 5, x minus 2. And I'm done. The next one's going to be a little trickier because a is not equal to 1. A is 2, B is negative 5, C is negative 12. So this time I'm looking for two numbers that multiply to give me negative 24 that add to give me negative 5. That's going to be negative 8 and positive 3. So what I do here is I take this negative 5x and I rewrite it as negative 8x plus 3x. And I'm just going to bring my 2x squared down and my minus 12 down. Now I have 4 terms, and I'm going to factor by grouping. Group these two together, group these two together. Here I have a common factor of 2x. Here I have a common factor of 3. And I have the 2 factors that match and the leftover part. Again, if you want to think of this using the area model, it might be a little easier for you. So we're going to take the 2x squared and put it in the top left, the negative 12 and put it in the bottom right. And then we're going to split that negative 5x up, just like we did here with these two numbers, minus 8x plus 3x. And then you just look to see what these two have in common. They share a factor of 2x. These two share a factor of 3. These share a factor of x. And these share a factor of minus 4. So either way, we end up with 2x plus 3 times x minus 4. Same thing. And then finally, I showed you a slip and slide way. If you really struggle with factoring, this way will work. It's not very mathematically sound, but it works. So we're going to slip this 2 down here with the 12, and it's going to become x squared minus 5x minus 24. We're just going to multiply that negative 12 by the 2. And then this is an AC equals 1 factoring problem. So we have A equals 1, B equals negative 5, C equals negative 24. So the two numbers that multiply to give me negative 4 that add to give me negative 5 are negative 8 and positive 3. So then I factor negative 8, x plus 3. Then I have to slide that 2 back under. I multiplied it there, so now I have to come back in and divide it. And then I simplify. X minus 8 over 2 is 4. And then I move this around because 3 halves doesn't simplify. It's already simplified. I move that around and it becomes 2x plus 3. And you can see I got the exact same thing here that I did here and here. So it's 3 different methods. Whichever way works the best for you, factoring is really important. And so you're going to want to be sure you can do one of these methods pretty quickly, the trinomial or the slip and slide with boxes, area model, or with grouping. And hopefully your factoring is getting stronger and stronger and better every day.